This lesson is surface area of cylinders, okay? And if we look at the cylinder over here that's already in its three-dimensional shape, you can see that the top and the bottom are the bases, and the bases are circles. And so there's going to be two congruent bases, and then this line here is the radius. Okay, and then this area here is the lateral surface, which is in the shape of a rectangle. And then we can find the height of the cylinder either drawn from the center of the circle down to the center of the circle here, and that would be a right angle with the radius to the side, or you can look at it in the net form right here, and so that would be the height. Okay. So those are the parts of the cylinder. All right, so the lateral surface in a cylinder, the lateral surface is the curved surface here. It looks like it, but they actually just use the definition. It's the lateral surface, but it's in the shape of a rectangle in the net. Okay, but it looks like it's curved there on the picture. And so then the total area includes the lateral surface, or the rectangle in the net, and the two bases, which are in the shape of a circle. So the formula for the lateral area is 2 pi RH, and the total is 2 pi RH plus 2 pi R squared. All right, so we look here, and we want to put the exact answers here, okay? So, and that means we want pi in our answer. So lateral, so I'm just going to write the formulas. We have 2 pi RH, and that is for the lateral area, and this is a cylinder. So we're going to multiply 2 times pi times the radius is 3 times the height, which is 7. So that is 2142 pi. Okay, and now for the total area, we're going to add to that these two circles. The area of a circle is pi r squared. The radius is 3, so that is 9 pi. And there's two of them, so 2 times 9 is 18 pi. So we're going to add 42 pi and 18 pi, and we get 60 pi is the total area. So please pause and try and do the next one. Okay, I hope you did pause. We have 2 pi RH for the lateral, and this is a cylinder. So we have 2 times pi times the radius, which is 3, times the height, which is 6. So that is 18. For some reason it's 36, but I just want to double check because I hate putting the wrong answer online. So 18, yes, 36. So this is 36 pi. And then to that we're going to add the area of the two circles. And again, pi r squared. So that is 9 pi, and there's two of them. So 2 times 9 pi is 18 pi. We're going to add 36 and 18, and we get 54 pi, and this would be inches squared. Okay, now we have example 2, and it's a little hard to see, but this says this is supposed to say 7 to the square root of 2. Just let me make that a little bit bigger. And now this is kind of an optical illusion when you're looking at a cylinder drawn this way, because it's a two-dimensional drawing of a three-dimensional shape. So even though this leg of this triangle and this leg of the triangle do not appear to be the same length, they have to be, because they're both radiuses of that circle. So those are always going to be 45, 45, 90 triangles. So if the hypotenuse is 7 to the square root of 2, x to the square root of 2, the radius has to be 7. So now we have all the information that we need. We have 2 pi RH, which is 2 times pi times 7 times 5. So that is 70 pi. And then we have the area of the circle is pi r squared, and so 7 squared times pi is 49 pi. But there's 2 of them, a top and a bottom. So 2 times 49 is 98 pi. So we have 168 pi feet. And again, these are cylinders. So please pause and try the next one. Okay, hopefully you did. Now this one maybe, hopefully you remember, but again, this is a 45, 45, 90 triangle. Let me draw this one a little bigger. So we have 45, 45, 90. We have x, x, and x to the square root of 2. And our picture is telling us that x to the square root of 2 is equal to 10. So hopefully you remember that when that is an integer, x is going to be half of that to the square root of 2. If not, you could solve for it. You would say x to the square root of 2 is equal to 10, and you would divide both sides by the square root of 2, and you get x is equal to 10 divided by the square root of 2. Can't leave the square root of 2 in the bottom. We have to rationalize the denominator, and that's where we get 10 to the square root of 2 divided by 2, and 10 divided by 2 is 5. So each side is 5 to the square root of 2. So that is our radius. So we have 2 pi RH. So 2 times pi times 5 to the square root of 2 times 4. And the way that you write that, we're going to, pi is going to be at the end. You're going to multiply 4 times 5 times 2. So that's 40. So it's going to be 40 to the square root of 2 pi. That's how you would write that. And then we need to add the 2 bases. The base is 5 to the square root of 2 squared pi. And that's going to be, if you remember, it's 5 to the square root of 2 times 5 to the square root of 2. 5 times 5 is 25. The square root of 2 times the square root of 2 is 2. And so that is 50 pi. And that is one circle, and there's 2 of them, so 2 times 50 is 100. So this is the way you write it is you just write 100 pi plus 40 to the square root of 2 pi. Okay, that's your final answer. You can't simplify that or add those together. So that is the exact answer. And I think that's actually the last example. Let's see. Yes, really short, so hopefully you don't have any trouble with this, and good luck.